Welcome to this lesson on potential energy. Potential energy is one of the fundamental forms of energy in physics, representing stored energy that has the capacity to do work. Throughout this video, we'll explore what potential energy is, how it works, and where we encounter it in everyday life. Potential energy is defined as energy that is stored in an object due to its position, configuration, or state. The word potential here means that this energy has the ability to be released and converted into other forms of energy, particularly kinetic energy. Think of it as energy waiting to be used, held in reserve by virtue of where something is or how it's arranged. Here's a crucial concept to understand. Potential energy has the potential to become kinetic energy when released. This is why it's called potential energy. For example, when you hold a ball above the ground, it has potential energy. The moment you release it, that stored energy converts into kinetic energy as the ball falls. This transformation between potential and kinetic energy is fundamental to understanding how energy works in physical systems. There are two main types of potential energy we'll focus on. First is gravitational potential energy, which is energy due to an object's height above the ground. The higher an object is positioned, the more gravitational potential energy it possesses. Second is elastic potential energy, which is the energy stored in stretched or compressed objects like springs, rubber bands, or bowstrings. Both types represent stored energy that can be released and converted into motion. The formula for gravitational potential energy is P equals mgh. Let me break this down. M represents mass measured in kilograms. G is the gravitational acceleration, which is 9.8 meters per second squared on Earth, and h is the height above a reference point, measured in meters. To calculate gravitational potential energy, simply multiply these three values together. The result tells you how much energy is stored due to the object's position in a gravitational field. Elastic potential energy uses a different formula. Pe equals 1/2 kx squared. In this equation, k represents the spring constant, measured in newtons per meter, which tells us how stiff the spring is. X is the displacement from equilibrium position, measured in meters, meaning how far the spring is stretched or compressed from its natural length. Notice that displacement is squared in this formula, which means that doubling the stretch increases the stored energy by 4 times. Let's look at some real-world examples of potential energy. Water stored behind a dam has enormous gravitational potential energy due to its elevated position. A drawn bow and arrow stores elastic potential energy in the bent bow, ready to propel the arrow forward. A roller coaster at the top of a hill has maximum gravitational potential energy, which converts to kinetic energy as it descends. Even batteries store potential energy in the form of chemical energy, which can be released to power devices. Let's summarize the key takeaways. First, potential energy depends on position or configuration, not on motion. Second, potential energy can be converted to kinetic energy when conditions change, such as when an object falls or a spring is released. Third, in closed systems where no external forces act, potential energy is conserved, meaning the total energy remains constant even as it transforms between different types. Understanding potential energy helps us analyze everything from simple machines to complex energy systems in nature and technology.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.